non-math students, many of them have confusion in changing the position, velocity, acceleration, they have confusion in differentiation, integration and all. I'm going to give a very quick clarity about it. I'm going to see the conceptual clarity questions because many of them may have doubt. In this point, always acceleration is acting downward, minus g. Here also, acceleration is acting but velocity is not there. So it depends upon the condition. Non-math students, many of them have confusion in changing the position, velocity, acceleration, they have confusion in differentiation, integration and all. I'm going to give a very quick clarity about it. Is if you want, if I say any graph like this, is slope. Slope is nothing but dy by dx. This already I have taught you the slope is equal to that. And one more thing, if you want some graph is given like this, if you want to find the area of it, some x and y axis, some physical quantity they have been given, but I'm not mentioning here. If there is an area covered by this graph, what we can, if you want to find, what you should do is, do integration. This is very important, right? Integration is must. So, in which thing we should do integration, in which thing we should do differentiation. For slope, what we should do, for integration, what we should do, for area, what we should do, I am going to do it and see. Portion that is the distance and velocity, right? So, we can say that there is a formula, right? That is velocity is equal to distance by time. If you see here, if I draw a graph like this with the quantities like distance here in y-axis and time here, if I draw a line, here if you see, I can write dy by dx is equal to d by x. That is here, if you see in y, d is there, in x, there is a time, right? That time is there. So it means velocity. So here what happens is, your slope is velocity. Further, what you should do is, if you want position to velocity, what you should do is, do differentiation. It's very important. Differentiation is very important. Here, if you should differentiate, and you will get the answer. If you want differentiate with time, I will write differentiate with time. Integration. If you see here, one more thing I can write here is differentiation also you can write it d by t is equal to v. Here d is equal to v dot t. So here the same thing will come here, that is how we have done here, same thing here you should do for acceleration velocity. For velocity, displacement is smaller than velocity. Velocity is smaller than acceleration. So I can write here differentiation with time, you will get the acceleration as a slope. Here you will get the area, here you will get the slope of velocity. Here you will differentiate with it time, what you will get is, here also you will get the slope. Should integrate I will write the formula again and show you how it is happening. Acceleration is velocity by time. If y is v, time is x, what happens? dy by dx is slope you are getting as acceleration. But if we do like this, acceleration into time, you will get the velocity. So it is nothing but the area, integration you are doing. If you do like this, if you put the integration sign, acceleration into dt, definitely if you do like this, it is an integration, you will get the area of this graph, that is the velocity. So that I think you can understand, but don't do this thing, very, very important thing. If you do like this, if you do with a time like this, otherwise divide by time, what happens? Nothing, you will get position, that is a distance. If you multiply with time, what happens? Nothing you will get, because x into t, nothing is, the meaning of this, nothing is there, because x into t, x by t is velocity, x into t, there is a no meaning, right? So definitely you can use it. Now we are going to see the conceptual clarity questions because many of them may have doubt, many of them may have this type of thinking that which is whether it is correct or wrong, you will know by this question. That is, if you see velocity is increasing, then acceleration should be increasing, right? You may think I am asking a question that is acceleration may be decreasing, whether it is actually correct or wrong, whether there is any case can happen. If you think you really know, definitely say in the comment. So if you see velocity is increasing but acceleration is decreasing, there may be a case like this. If I take an example, I have written here, take an example like this. If I go in the starting at t is equal to 0, I have started the bike with 0 meter per second. I didn't raise it itself, the speed is now 0 in the starting. Finally, what I have done is, I went to 12 meter per second. Finally, I am going to 16 meter per second. If you see, the velocity keep on increasing. But if you see in this particular time, t1 and t2, here if we calculate exactly the acceleration, if you can see here, that is 12 minus 0, right? Acceleration is nothing but change in velocity, right? So you can also take the time also same. T, if you see, that is 12 meter per second square. Here if you see, that is acceleration is equal to, we can also take for more understanding, you can take time is equal to 1 second also. So we can get the actually correct answer. So there is 12 meter per second. If you take acceleration here, 2 is equal to 1 second. Here also, if you see here 16 minus 12, change in velocity, right? Change in velocity is equal to acceleration divided by time. Change in velocity divided by time is equal to acceleration. So we are using it. That is 16 minus 12 is equal to divided by 1 second I will take. That is 4 meter per second. If you see here the acceleration is 12 meter per second, but here the acceleration is just 4 meter per second. See, this is a condition it may happen. We can't say directly that whenever if you see velocity is increasing, definitely acceleration should increase. So it is a wrong thing. Here the case can also happen like this. That's why I say it can happen. So if you ask me, unless I will write true also. True. If you see velocity is decreasing, you may think again velocity increasing means acceleration should be decreasing. Here I have asked acceleration may be increasing. If you see, just what you should do is take this condition in reverse way. That is, in starting I was having a velocity of 16 meter per second, and finally if you see, that is I am going in 12 meter per second. Again if you see, in final situation at v final, what happened? Velocity becomes 0. I have become at rest. So if you see here, you will get the acceleration, same thing you will get, but in negatively. That is, I can explain you the same situation in the reverse way. That is, if you take here starting, that is 16 meter per second, I am going in the speed of velocity. So again I am going in 12 meter per second. Here finally at v final I am going with 0 meter per second. The thing here is, if you see here, from here to here, that is m to here, if you see velocity is decreasing. Velocity is decreasing, right? So velocity is decreasing, but if you see acceleration, here it is minus 4, right? Last you got 5 only, right? At last situation we have got the answer, that is acceleration is equal to minus 4 meter per second. Acceleration is equal to minus 12 meter per second. The reason negative comes is because it just shows that we are going, the velocity is decreasing, so we are going in the against velocity. That is the reason is. But if you see in a magnitude, if you see acceleration is increasing, it is 4, it is here, it is 12. So acceleration is increasing. So that's why I'm saying there is both case can happen, whether velocity is decreasing. When velocity is decreasing, we can say acceleration may be increasing, otherwise acceleration may be decreasing also. So there is both case can happen definitely. So final situation, that is here the answer will be also Okay, it is true. Finally, acceleration may be non-zero. That is, acceleration may be non-zero, but it's more than zero. It could be any number, but velocity of the object is zero. Happens. The reason is, if I throw, it's a very, very important case. You may learn also. That is, if I throw a ball like this, straightly with uy velocity, that is in x-axis, sorry, in y-axis, if I throw a velocity u, if I go and throw like this, if you see, exactly at the highest point, the maximum becomes zero, right? Here, if you see, in this point, always acceleration is acting downward, minus g. Here also, acceleration is acting, but velocity is not there. So it depends upon the condition. If velocity is zero, acceleration may be also non-zero. So this is a three important case. If you see, for thinking something like a normal way, that is velocity increasing, acceleration increasing, like that, is not the actual thing. So it will be different cases also. So it is true.
Five-star general, who you know comparable.